Hi, everybody. We're going to do a second video here. Um, we have simplifying radicals from the first video. We saw that we had two different methods to do some problems. I'm predominantly going to focus on factoring out the perfect square method. So here's some examples to do. And recall that a radical is just an exponent, right? The radical a is just a to the 1/2 from chapter 7. And realize that in chapter 7, we were allowed to take AB quantity squared and split that up into a squared times b squared, or a divided by b quantity squared and split that up into a squared divided by b squared. We can do the same thing in chapter 10 with radicals. So radical AB can be equal to radical A times radical B, and radical of A divided by B can be equal to radical A divided by radical B. And sometimes it's going to make sense to go from right to left, or from left to right, depending on what you're doing. So here's some examples. You can try them first if you'd like. Pause the video. But I'm just going to go here and see what I can figure out. Oh, 54. 54. Let's see, 54 has... You might look at 54 and think, like I'm thinking, what goes into 54? Now, if we're using the perfect square method, we're going to check perfect squares. So 4 is our first perfect square, and 4 does not go into 54. The next perfect square is 9. Oh, 9 does go into 54. So we're going to say that this is equal to the square root of 9 times 6 times n, let's see, the biggest perfect square that goes into the end of the 7th is end of the 6th, leaving an n. So whenever you have an odd number here in the exponent, your biggest perfect square is an even number, one below it, leaving also n. So then we can take out the 9, and we can take out the end of the 6th, and we wind up with 3 on the outside, and n to the 3rd on the outside. That's the square root of 9. That's the square root of n to the 6th, leaving 6n on the inside of the radical. And we're done simplifying that radical. The next one, square root of 64 over square root of 9. Well, we can think of that. We don't even have to think of it this way, but we can think of this as the square root of 64 over the square root of 9, or the square root of 49 rather. And that's simply 8 over 7. And we're done. The third one here, an 8, an x to the 3rd, a 50, an x on the bottom. Now, we can start by simplifying this if we want to, inside the radical. So 8 and 50 both have a 2 in common in their numbers. So we have 4 over 25, and x to the 3rd divided by x is x squared. And this becomes 2x over 5. Notice we don't have to split up into two fractions. We can just move on if we want to. Now, if we hadn't done this with the numbers, well, that's the best way to do it. But if you hadn't done this with the numbers, you could have just done it with the variable and simplified 8x squared over 50. That would simplify to square root of 8x squared over the square root of 50. And 8 has a 4 and a 2 in it, so that would be a 2 on the outside and a 2 on the inside with the x squared. And the 50 has a 25 and a 2 in it, meaning this is like the square root of 25 times the square root of 2. And this is like the square root of 4 times the square root of 2 times the square root of x squared. So this 25 gives a 5, and this root 2 gives a 2. This x squared comes out also, So we have 2x root 2 over 5 root 2, and then the root 2's cancel. So you still wind up in the same answer that you did here, depending on what order you did things in, and that's fine. Two more examples, and then we'll do a little separate video on rationalizing functions. So let's see. We have a radical symbol and another radical symbol. Let's do order of operations. We'll do the radical symbol that's inside the radical symbol, because these radical symbols act like order of operations. So this is going to be equal to the square root of 50 y squared over, let's see, 9x to the fourth is just 3x squared. And then 50, we saw before, is 25 times 2. So this is equal to, this radical still on the bottom, right? This radical still on the bottom. Let's split this up. Let's call this radical 50 y squared over radical 3x squared. So this is going to equal radical 2 times radical 25 times y over radical 3 times x. Right, we took the x squared out. So this 25 is actually 5, so we have this is equal to 5y radical 2, and this is equal to x radical 3. Now we're not going to leave that radical 3 on the bottom, but I'll show you that in the next video. We can leave that there for right now. Now here we have two things multiplied together, but you can combine everything. Look at the numbers and look at the variables separately. 14 is not a perfect square. 7 is not a perfect square. 3 and 2 aren't doing much right now. But we can look at this way. 2 times 3 times radical of 7 times 14 times radical of t times t squared. So this 14 doesn't do much for us now, but it can be combined with a 7. So we can look at the 2 times the 3 as 6. We can look at this radical as being 7 times 2. And we can look at this radical as being t times radical t. So this t squared is coming out as a t. This t squared is coming out as a t. And then this t here, this one that's by himself, is staying in. Now we have two 7s here, so these two 7s can come out of the radical. If you want to multiply them together and make them 49 and then take them out, you can. But I'm going to call this 6 times 7 times radical 2 times t times radical t. 6 times 7, of course, is 42. Then I'm going to move things around a little bit here. We're going to make this 42t, because those are the things that are outside the radical, times radical 2t. And we're done. I'm going to show you more in the next video on rationalizing functions, and that'll be it for this chapter.